Let's start with chapter 1, number system today. When you came to school, first came to school, you took admission in school, your nursery teacher taught you something in maths. What was that? The first thing that she taught to you was the number 1, then 2, 3. She taught you counting. She taught you counting numbers. So, such numbers are called natural numbers. You first, in your school, you were taught natural numbers, 1, 2, 3, 4, so on and on and on, which are endless. Then your teacher introduced you with 0 also, that there exists a number 0 before 1. So the name changed to whole numbers. Then when you came in class 6, you were introduced with some negative numbers also. That in our world, there are some negative numbers also. You were given some examples like depth of the sea, loss. They are all denoted in negative. So, such negative numbers together with positive numbers were known as integers. Then you were also introduced with some numbers which were of the form P by Q, where P and Q were integers and Q was not equal to 0. We named such numbers as rational numbers. We named such numbers as rational numbers. This was taught to you in class 7th. So till now you know only these types of numbers: natural number, whole numbers, integers, rational numbers. Now when we talk about a number line, all of you know about a number line? On a number line, we have the numbers, all kinds of numbers. Firstly, the natural numbers, then 0 is also there, then integers are also there, and then rational numbers are also there. Where are my rational numbers actually? They are in between two integers. Suppose if I say here, so this is 3 by 2. 3 by 2 is a rational number, which is basically 1.5. So all my decimal numbers are actually rational numbers. Here if I say I have 5 by 2, which is actually 2.5. So all these numbers can be represented on this number line. Now this number line has how many numbers? It has infinite numbers. It has infinite natural numbers, infinite whole numbers, infinite integers, infinite rational numbers also. So, what can you say about two rational numbers? How many rational numbers are there between two rationals? What can I say about rational numbers between 1.5 and 2.5? There are again infinite rational numbers between any two rational numbers or any two numbers. Fine. Now, there is one more category of number which is not rationals, which lie on this number line. Number line basically further it will be called as real number line. So, what are those numbers? Those numbers are called irrational numbers. So, something which is not rational is irrational. So, what can I say? No, they are not of the form P by Q. Then what is their form? They are generally written in the root form. The numbers in the root form are called as irrational numbers, the square root form. Okay? Now, under this root form, you need to keep it in mind that the number m that we are taking under the root, that m should not be a perfect square. Why so? Let's see some example. If I take root 4, that will be 2. Root 9, that will be 3. Root 16, that will be 4. So they are not irrationals, they are rationals. So we should keep it in mind that under the root we should not have a perfect square. We can have some different numbers, like we can have root 2, root 3, root 5, root 7, root 23, so on and on and on. But it should not be a perfect square. So there exists a real number world. Real numbers which exist in our world, which are not imaginary. The real numbers. So real numbers basically has two categories. One is rationals and the other is irrational. They are totally different categories. They are anything which is rational cannot be irrational, and anything which is irrational cannot be rational. So my rationals are of the form p by q and my irrationals are of the form root. So all the numbers that we have discussed are falling under the category of rational numbers. The smallest was natural numbers. Then we had whole numbers. Then we had integers, which included some negative numbers, not some, rather infinite negative numbers. And then we came to rationals. Now rationals and irrationals are totally different categories which fall under real numbers. Now if I want to ask you, are all naturals whole numbers? So yes. Why? Because all natural means 1, 2, 3, so on and on. Obviously they are whole naturals. But if I say are whole numbers natural numbers, but that's not true. Why? Because 0 is such a number which is whole but not natural. So what's happening? My all natural numbers are whole numbers, my whole numbers are integers, my all integers are rationals. But the reverse is not true. The rationals are not integers, the integers are not whole numbers, and the wholes are not natural numbers. So generally questions for 1 mark or true or false come like this also. And irrational does not have any categories under it. Now let's discuss the decimal expansion of real numbers. Already we've discussed that real numbers are of two types, rationals and irrationals. The rationals are of the form p by q and the irrationals are of the form root. So they must be having some decimal expansion. So let's discuss that. So let's first discuss rational numbers. All of us know that rationals are of the form p by q. So let's take an example. I'm taking an example like 5 upon 2. This is a rational number. And I'm also taking 10 upon 3. I've taken two different rational numbers. So let me divide 5 by 2. What's going to happen? I'm going to get a remainder as 0. But if I divide 10 by 3, what is happening? I'm again and again getting remainder as 1. So what do you think? Is this division going to stop? No. So there are two categories in rational numbers. When your division stops, and one when your division does not stop. In this also what is happening? It is repeating. Every time the remainder is repeating. So when it is not stopping, then also there are two cases. The first case is when the number is repeating. The number is repeating itself, or the remainder is repeating itself. On the second case, the remainder is not repeating. So there are three possibilities. Which I can say in a decimal expansion. The first is when my division stops. We call this as terminating decimal expansion. Terminating decimal expansion. When my division is not stopping but it is repeating again and again, then we call this as non-terminating repeating. Or recurring also we say. But if it is not even repeating, there are different numbers appearing here. So it will be non-terminating, non-repeating. I don't think so there is any other form of a decimal expansion except these three. So what do we observe? We observe that 5 by 2 was a terminating decimal expansion. And 10 by 3 was a non-terminating repeating expansion. Non-terminating repeating decimal expansion. Let me take one more example with you. Any other? If I say 25 by 3, let's try to divide 25 by 3. What's going to happen? 25 by 3, 8, 24, 1 decimal 0, 3, 9, again 1. So if I again 1, that means again 10, again 9. So this 3 is going to repeat itself. So again this is non-terminating repeating. So if you try to take any rational number, it is going to give you only these two forms, the non-terminating and the non-terminating repeating expansion. So now finally we've come to the conclusion that when we talk about real numbers and we are having two categories, that is rationals and the other is irrationals, where rationals are of the form p by q and irrationals are of the form root, then their decimal expansions are, firstly, in rationals it is terminating or it may be non-terminating, recurring or repeating we can say. But when we have irrationals, then their decimal expansion is non-terminating and non-repeating. Let's see some examples. I can take an example here. Suppose I say 2.573. This is an example of a terminating. But if I say 1.3742 bar, so this bar basically represents non-terminating repeating. For repetition we put a bar. Whatever number is being repeated is known as is put under a bar. This is terminating and this is non-terminating repeating. Let me take few more examples. 1.3 bar, 2.76 bar. So these are non-terminating repeating. And we do also write them as in dot form, like 2.3777 dot. That means, what does this dot represent? It means it is not stopping, it is non-terminating. But when I talk about irrational numbers, I can say 2.10, 100, 100, 1 dot. What is happening here? The number 1 and 0 are not repeating in a fixed number, like it was 1 0 in 1 0 before, then 2 zeros, then 3 zeros, then 4 0. So a complete block is not repeating itself. I can just take some random number 3.462357, anything. There is no bar here, that means there is no repetition here. So any number which is not stopping and not repeating is a irrational number. And let me specify one more thing to you, one important number which is an irrational number, that is pi here. Pi is an irrational number. All of you know that pi is equal to 22 by 7. But that is actually an approximate value of pi. That is not the exact value of pi. So the exact value of pi is actually a number which is non-terminating and non-repeating. It is 3.14 dot. Now let's discuss a question. There we have to write 5 rationals and 5 irrationals between 2 and 5. Now when I'm talking about rationals, I can directly write them as terminating or non-terminating repeating. But here we'll generally write as terminating. So my rationals will be, I can write any number between 2 and 5, like 2.374. 2.493, 3.5, 3.429, 4.63, 4.9. I've written so many, rather more than 5. And when we are going to talk about irrationals, we are going to write non-terminating, non-repeating. So how are we going to write that? We are going to take any number between 2 and 5. Suppose I took 2.3. So I'll take one more number. I'll take 3 1, then 3 1 1, 3 1 3 4 times 1. So I'm going to form a pattern like this, in which it is non-terminating and even non-repeating. I can take one more, like 3.46, 466, 466, 4 times 6. Like this, I will form a pattern in which there is non-terminating and non-repeating. I can take one more, 3.72, 722, 722, 7, so on and on and on. 4.27, 277, 277, on and on and on. And one more I want, so 4.90, 900, 900. Like this, they are non-terminating and non-repeating. This was when I had very simple numbers like 2 and 5. But if I give you between two rationals, like here I have given you 2 by 3 and 7 by 5. So first of all, I need to know the decimal expansion of both of these. So I need to divide 2 by 3. So what will this be? Decimal 6, again 2, again same thing. So this will be 0.6 bar. And now let's see what is the decimal expansion of 7 by 5. Let's divide 7 by 5. Decimal 0. So it's 1.4. So I have these two numbers with me. I have to find 5 rationals and 5 irrationals between them. So let's talk about rationals. Rationals first of all. So I'm going to start from 0.6, not start, say 0.61 rather, and I can go till 1.39. I am not going to take 1.40. I'm not going to take 1.4, which basically means 1.40. So I want in between them. So I can go till 1.39. This is my range. From 0.61 to 1.39. I can write any number. 0.65, 0.99, 1, 1.26, 1.30, 1.35, anything. You can take up to 3 decimal place, 4 decimal place, but it will be a terminating decimal expansion. So that will be rational. Now I want to write some irrationals. So for irrationals, again I'm going to do rationals was terminating and irrationals are non-terminating, non-repeating. So from between these two, I'm going to take few numbers which are going to follow that pattern. So it will be 0.63, 633, 6333, like this. Dot, 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 dot. Let's write few more. 0.75, 755, 7555, 1.01, 011, 011, 0, so on and on and on. 1.16, 166, 1666, like this. 1.20, 200, 200, dot, dot, dot. So in this manner we can find some rationals and irrationals between any two numbers.